What's up? It's your old pal, Mr. Cook, and we are working on the Algebra 2 practice final. We just got through numbers 27 through 31, and now we're working on 32 through 36. Now, these first two problems, 32 and 33, are still part of Unit 4, and then we're going to start up the last unit that we had, which was the sequences and series stuff, so that ought to be pretty easy. Especially because, on our formula sheet, we have all of the exact same formulas that we had on our test. And remember how much that helped with the test. So this will help out quite a bit with these problems. Anyways, so starting off with this, if we have x to the 1/2 power and x to the 5/7 power, we just need to simplify it. So one thing that you can do is just, use one of these little properties here. So the property that we're going to use is when we have two numbers, two exponents that are multiplying together like this. If they have the same base, like x here, that means that we just add the exponents together. So that's all that we need to do. X raised to the power of 1/2 plus 5/7. Now, if you don't like adding fractions, I've got good news for you. Your calculator will do it for you. So 1/2 plus 5/7. You get that, but then you can turn it into a fraction really easily by just simply hitting second and then this little fraction and decimal button right here, so this one. And you get 17/14, so it's going to be x to the 17/14 power, which would be C. If you have one of these, it's about the same difficulty, 1/2 plus 5/7. You get the same decimal answer. And then the way that you turn this into a fraction is by hitting the math button in the first option. Change it to a fraction. See, 17/14. All right, so that's number 32. Now we do number 33. Given the graph of the radical function, write the equation and state the domain. Well, if you know anything about like transformations, this is the radical function, and it's just been shifted from 0, 0 up 4. And the only one that has a transformation of up 4 is this one, because it's the radical and then plus 4 outside the square root. So if you knew that, then, B is the obvious choice. If you didn't know that, that's okay. You can still just graph out the equation. Like, if you did square root of x minus 4, then, graph it. It's not going to look the same. Same thing with this one. X plus 4, so if I did x plus 4 instead, it's not going to look the same, see? The only one that looks the same is this one, square root of x plus 4. So it's square root of x, then get outside the square root, and then plus 4. See, so that one does look the same. It starts up top and then moves out. So there's the graph. And then, you don't have to worry about the domain because the rest of them are the same. So yeah, that's the answer for that one. Now we move on to Unit 5, which is the stuff that should be more familiar to you because we just went over it, just tested on it. Write the explicit formula of the nth term of a geometric sequence. So explicit formula for a geometric sequence, that's this one. So I have an is equal to the first term, which is 3, a1 equals 3, and then times the common ratio, which is -2, raised to the power of n minus 1. So 3 -2 n minus 1, that's B. So B is our answer for that one. Find the sum of the first 54 terms of the sequence. We better figure out what kind of sequence it is first because we have two summation formulas. This one for arithmetic sequence and this one for geometric sequences. That's for finite sequences, which this one is. So if it goes from -5 to -2 to 1 to 3, to 4 to 7, what keeps happening to the numbers? Do they keep multiplying by the same number, or do they keep adding by the same number? You should have guessed that they're adding by the same number because they keep adding 3 to get from one number to number. So that makes this an arithmetic sequence. So if it's arithmetic and we're looking for the sum, that's this formula right here. So let me write that one down. All right, so the sum is equal to n/2 times a1 plus an. And if you watch some of those videos that I went through for Unit 5, you know that n is the number of terms, so that's going to be 54, so 54/2. a1 is the very first term, which they give us, -5. And then an is the last term. We don't have the last term, so we need to kind of work a little bit beyond that. So to find any term that you want, any individual term, you use the explicit formula. So since I have the explicit formula, I can write that down. So let me find the explicit formula to find the last term. So the explicit formula is an is equal to the first term, -5, plus the common difference, so how much it keeps changing by, so it keeps adding 3 times n minus 1. And then if I'm looking for the 54th term, the last term, I just plug that in here, 54. And then I can just let my calculator do the rest of the work. So let's see here. -5 plus 3 times parentheses. 54 minus 1 is 53. And I get my answer, which is 154. All right, so my 54th term is 154. Now I just type this into my calculator. So 54 divided by 2 times parentheses -5 plus 154. And I get my answer, 4,023. So 4,023, there it is, C. All right, let's go to the last problem on this page, a word problem. A worker is paid 10 cents for a day of work. Each subsequent day, the worker is paid twice as much. Twice as much means that you keep multiplying it by 2, meaning that this is a geometric pattern. So twice as much as the previous day. How much money has the worker earned at the end of the 20th day? So that's going to be the total number of days that they work. So this is going to be, if it's the total that they make at the end of the 20 days, that's adding all the values together. Adding all the values implies that we're going to be using the summation formula right here. So let me write it down first. The sum of a geometric sequence is equal to the first term times parentheses 1 minus the common ratio to the power of n over 1 minus the common ratio. All right, so let's put all this stuff together. N is the total number of terms, which is going to be 20 because that's how many days we're adding up. So 20 days, so 20 goes here. R is the common ratio, or what it keeps multiplying by each time. It keeps multiplying by 2, so those R values are 2's. And A1, of course, is the first term, so how much you make on the first day. So a worker is paid 10 cents for first day of work, so 10 cents, 0.1. That's not a lot of money to start off with, but let's see how much money that you get at the end of those 20 days. So we plug this stuff in. You got to be careful with this. Make sure you put parentheses around the top and parentheses around the bottom if you're using one of these calculators. So you do 0.1, parentheses, and then you do a second set of parentheses for the top, and then you do 1 minus 2 to the 20th power. That's the top part, divided by the bottom part in parentheses, 1 minus 2. And then you get your answer. So that's going to be, let's see, $104,857.50. So A would be your answer for this one. Okay, cool. So that's the end of this page. That's number 32 through 36. And we're going to continue with the last couple problems. It looks like all of those are, yeah, those are all Unit 5 also. So they're all, going to be found on with these equations here. Okay, so that's the end of this video, and on to the next one.